Healthcare doesn't move in batches, it happens in real time. Every heartbeat, every lab result, every patient admission, every connected medical device generates information that can change the course of care. But too often, that data remains trapped in disconnected systems, arriving minutes, hours, or even days after critical decisions have already been made. In today's healthcare environment, every second matters. Clinicians need immediate access to the latest patient information. Operations teams need live visibility into capacity, staffing, and resources. Executives need trusted insights that reflect what's happening now, not what happened yesterday. Streaming real-time data transforms healthcare from reactive to proactive. It enables organizations to detect patient deterioration sooner, optimize hospital operations, accelerate clinical workflows, and deliver more personalized, coordinated care. By continuously moving and integrating data the moment it's created, healthcare organizations can turn thousands of isolated events into a single living view of their patients and their operations. Because when data flows in real time, better decisions happen in real time, and better decisions lead to better patient outcomes. Let's see how IBM Watson X data integration can meet this challenge. In this scenario, the fictional Lakeview Regional Health System is tracking a viral outbreak in real time. The diagnosis information is updated in Postgres after every patient interaction and diagnosis. We need to ingest this data in real time and enrich it before sending it on for analysis. Let's start by looking at the current data in our Postgres database. Clicking the Last Record button shows us the record count. It looks like this table has 4,999 records in it. Let's head over to Watson X data integration and get started with tracking this outbreak. Over in Watson X data integration, we'll open our existing project and create a new real-time streaming data flow. We'll call it Outbreak and create the flow. From the Sources menu, we'll select the JDBC Query Consumer and open the configuration pane. Our system administrator has given us a pre-built connection to the Postgres database, so let's open the connection drop-down and select JDBC Postgres. Next, we'll paste an SQL query that will pull in those 4,999 records from the conditions table in Postgres. We'll also paste the correct offset column name and save our work. Let's preview our data flow to make sure we can connect to the database. That's the result we were looking for. Let's exit the preview. Next, we want to filter this data based on our requirements. We'll close the Sources menu, open the Processors menu, and select the Stream Selector processor. After opening the configuration pane, we'll add a value to the conditions. For this requirement, we'll paste expression language that keeps any record with COVID-19 listed in the description, and then save our work. For the next step, we need to add a couple of trash destinations for testing purposes. After typing trash in the search box, we can add the 2 trash destinations and connect the second one. Our data flow looks pretty messy, so we'll arrange the tiles and then preview the data. We want to see how the data was divided, so we'll view the preview in the Stream Selector stage. We need to ensure that COVID-19 diagnoses are being sent to Output 1. We can see that records 0, 1, and 2 are all going to Stream 2, and they don't have a COVID-19 diagnosis. Record 3 was sent to Stream 1, and that diagnosis was for a suspected case of COVID-19. This proves the Stream Selector is working the way we wanted. We will exit the preview. We need to enrich this data stream with additional information that our researchers need to monitor this outbreak. The research team wants to know which immunizations were received by anyone diagnosed with COVID-19. We'll need to look up that data from another table and add it to the stream. The trash destination for Stream 1 was only temporary, so we'll delete it. After clearing the search box, we can open the Processors menu and add the JDBC Lookup processor, which we will connect to Stream 1 and then rearrange our canvas to look more organized. To configure the processor, we'll first add the pre-built JDBC Postgres connection. Next, we'll paste an SQL query that will bring in the data from the immunizations table in Postgres. After saving our work, we can preview the data to see the new columns added to our data flow. Here we can see that the patient's immunization record was added to the diagnosis. This is exactly what our research team wanted, so we can exit the preview and proceed to the last step. The research team has a Kafka stream they are using to gather real-time data about the outbreak. We need to connect to it. After closing the processors menu, we can add our Kafka producer target to the canvas. In the configuration pane, we will add the proper broker URI and publish to the research team's outbreak topic. We'll save our work and run one last preview to make sure everything is perfect. Now that we know everything is correct, it's time to exit the preview and run the job. The job metrics are showing for the Kafka stage, but it is much more interesting to see the data move through the stream selector stage. As new diagnosis records are added to the Postgres table, our real-time streaming data flow will automatically ingest those records, enrich them with the immunization information, and write them to the Kafka stream. And that's it. In a matter of minutes, we've created a streaming data flow that will feed the organization with real-time updates for every COVID-19 diagnosis that happens in the network. This enriched streaming data will definitely help the organization monitor the outbreak in real time. Healthcare organizations can't afford to wait for yesterday's data to make today's decisions. The future of healthcare depends on the ability to continuously connect people, systems, applications, and devices, transforming a constant stream of information into trusted, actionable insight. IBM Watson X data integration is built for that reality. By enabling secure, scalable, real-time streaming data integration, IBM helps healthcare organizations move critical information as it's created, connecting electronic health records, medical devices, laboratory systems, operational applications, cloud platforms, and AI initiatives without disrupting existing investments. The result is a healthcare ecosystem where clinicians have the information they need, right when they need it. Operations teams can respond to changing conditions immediately, and leaders gain the confidence to make decisions based on the most current data available. From improving patient outcomes and accelerating clinical workflows to strengthening operational resilience and powering the next generation of AI-driven healthcare, IBM Watson X data integration provides the foundation for a truly real-time enterprise. Because in healthcare, every moment matters, and when your data moves in real time, your organization can act in real time. Thanks for watching.